Yes, class. Good evening. Am I audible?
Yes, ma'am.
Aisha, Aram, Fatima, Mahamdulillah, all have joined. All right. So any doubts from the last lesson that we have finished it already? Your angular motion plus horizontal motion. That is your whole motion in a plane, projectile motion, since your motion in relative velocity has already been deleted. So did you people revise it? Aisha, Maha, you have your maths exam on next Saturday, no?
Yes,
Oh,
yes.
sorry, not Aisha Maha. Aisha and Aram. है ना?
Yes,
Saturday,
ma'am.
it's on Saturday, no? Okay, then as decided, I think you can give the test on Monday.
Yes.
Okay, if there is any issue because of your exams, all of you, not just for both these girls, just text me on WhatsApp. I'll postpone the test. Otherwise, I'll suggest you to give it on Monday only because it's a short lesson. Major portion has been deleted only. Angular projection and horizontal projection questions will be here from here only. Fine. So I'll say if you give the test on Monday, because you both will also get a gap to study for your maths test for Saturday. Otherwise, if the test shifts, it will shift on Wednesday. So there will be lesser time left. Fine. So we are starting with chapter number 5 of NCRT, that is Newton's laws of motion. So chapter 5, this is your from your NCRT part 1 only. Till gravitation, your book 1 begins, lasts. Gravitation, rotation, and work, energy, and power. These three lessons, these are left from here. So this is mainly a part of your unit 3. Third unit. So first unit was about physical world and measurement. First chapter was about physics. That chapter does not come in your exam. Then you have chapter 2 where you deal with units and dimensions. That is your dimension analysis, and error analysis is not a part of your syllabus, but dimension analysis and all these topics. Then chapter 3 was your motion in a straight line. Chapter 4 was your motion in a plane. And now this is your chapter number 5, that is laws of motion. Now, see, in this chapter, no, many things are simple. Most of the topics, they are simple. But all the forces get applied together. So ultimately, you'll have to draw a free body diagram. We'll see how to draw a free body diagram. But you will have to combine everything that you study. And this is one of the lessons that is very important, not only for your class 11th examination passing, for your knowledge also for class 12th. All right, this is a very basic chapter for physics apart from your, and from your mechanics portion. This is a very core chapter because all the forces, usage of all the forces, how forces balance each other, and obviously Newton's laws of motion. The laws of motion are what? These are the laws given by Newton. So Newton's laws of motion, these are also very important. So free body diagram, we'll see class in this lesson. No, I'll suggest you, please do it simultaneously. After the class, you have your classes on Monday and Wednesday. So either on Monday and Wednesday, after the class gets over, revise at least whatever is done in the class. All the points, note theoretical points that have been written in the class, or the numerical that we do. At least do that much. Just do that much, because if you lag in this chapter, the rest of the concepts will not work, because here you will have certain forces. Then as the chapters will increase, your number of forces will get increased. So there what will happen? Concept will be the same, but you will not get the usage of it. Pulley system is here. Pulley system you will see. So pulley system will be used in another form also. Fine. So this is a very basic chapter. So we'll start with Newton's laws of motion only. Before we start with the first law, one quantity exists that is known as inertia. Inertia, all of you are aware of, I hope, but I'll just repeat it. See, this term inertia was actually introduced by the scientist Galileo. Let me write it down. The term was introduced by Galileo. Fine. So inertia means what? Inertia is a kind of resistance which we see, where you resist one state of body. What is meant by state of motion? See, if I'm sitting right now, this is one state that I'm at rest. This is my state of rest. If I am walking, that is the state of motion. Fine. If I am changing my direction, that is the state of changing direction. So state means what? At whatever present condition you are present, whatever present condition you are exhibiting. For example, if I'm sitting right now, I'm still, I'm not moving. The chair is not moving. We sit in a vehicle also, but the vehicle moves. That's why we had the concept of relative velocity also, which we had studied in chapter number 3. So here what will happen? I am at rest. So this is my state of rest. So states, you understand? State means the present condition that is exhibited by the body, and it can be any body. Now, if I am at rest and I am not able to change my state of rest, I am able to sit in the state of rest. Even somebody pushes me, or they will win. If somebody comes and pushes me right now, what will happen? I'll push forward in the direction to which the force has been applied. But in that duration, for a small fraction of second, what will happen? My body will slowly, first I'll overcome the state of rest, then I'll go into state of motion. Understood this fact? Initially I'm at state of rest right now. If some forces are applied on me or somebody pushes me right now, what will happen? First I have to overcome the state of rest. I am at rest. It won't happen. Somebody pushes me and I'll be easily swifted away. Why? Because I am initially at rest. So my body is in the state to maintain rest. Now, if somebody pushes me right now, then what will happen? First, my body will overcome the state of rest. Once I have overcome this state of rest, then after overcoming the state of rest, then the state of motion will begin. So this inability of the body to change its state of rest or motion, that is known as inertia. For example, the best examples that we see from our daily life is when we travel in bus, for example. If a person moves out or jumps out of a moving bus, you must have seen, I don't know whether in your country this happens or not. In India, especially, this happens a lot. The bus starts moving and the passenger starts jumping out of the bus. So what happens? Passenger moves on the road as well. Passenger was inside the bus. Fine. Bus was in the state of motion. So it means the person was right now in the state of motion. Fine, because the bus was moving. If the person directly jumps on the ground, what will happen? Is it possible without inertia that the person is able to change its state? No, because inertia exists in nature. Inertia is just a property. Don't think inertia is a force that is acting, firstly. So what happened? The person was inside the bus was moving. The person jumped out of the bus. Now what happened? The person's state of motion was what? It was state of motion. It wasn't state of rest. Now the person has to be in state of rest. But what happened? Because first we have to overcome the state in which we are. Then we begin the other thing. So since the person was right now in the state of motion, because the person was in the bus, inside the bus. So when the passenger drifted away from the bus or jumped out of the bus, so what happened? Because he was in a state of motion. Now firstly he is overcoming the state of motion, and now what is happening? Then he will be in state of rest, or in whichever state he wants to be. Or even you can take this example, whenever we are sitting inside a car or a vehicle, if suddenly a brake stops, we are tend to push forwards. Reason is what? If we were in a state of rest, we were sitting fine. As soon as your bus starts, let's take this example, you are sitting inside a bus, you are in a state of rest, bus is not moving. Now suddenly bus has started, so we tend to move a bit forward. So what happens in this? Our body, the upper body that was completely in state of rest right now, we were in state of rest, Now what happens? Since the bus has began its motion, bus moved suddenly. Now my lower body, which was in contact with the earth, with the floor, or you can say directly, you can say with the chair of the or the seat of the bus, it was at rest. Now, as the motion began, the lower half of the body first has to overcome its state. That is, from the state of rest, it has to go into state of motion. Till that time that occurrence occurs, the upper body tends to move forward along with the bus. Then we get acclimatized to it. So this property that we are able to resist our state, whatever state be it, whether rest or motion, this property is known as inertia. I never consider it as a force. Inertia is not a force that is occurring you, which is pulling you or pushing you. Inertia is a property. We name this tendency, the tendency of us to resist the state, as inertia. Got it? So inertia is not a new term. In your lower classes, all of you must have heard of the term inertia. Inertia is what? It's the inability of the body to change its state of rest or uniform motion by itself. By itself means what? If some external force gets applied or somebody pushes me or pulls me back. So even if the vehicle is moving, I tend to move backwards only. Fine, because that was external force. But naturally, what will happen? Our body tends to move forward. So the things that occur naturally without any force by itself, that property we say inertia. And it's the property of a body, not a force, because many students get it confuse inertia with as a force. They think that this pushing that is occurring, this is because of a force that is coming, that is known as inertia. No, this is not the case. Inertia, we have just named this property, this tendency of the property, we have named it as inertia. So it's a property of the body. And one more point, this completely depends on the mass of the body. This is one such quantity that depends on the mass of the body. When we'll do rotational dynamics, your rotational forces that will come, there you will have moment of inertia as well. So that will be relating to your rotation. Right now, inertia means what? Yes, one more point that I was mentioning you was it depends on the mass of the body. Inertia depends on the mass of body. Inertia, this depends on the mass of the body. So if a larger body mass is there, body surface area is larger, be it any body, what happened? Not only this is applied to human beings, you can take the example of any other object as well, non-living object as well. Now, what happens if the mass is greater, larger is the surface area, inertia will apply, that will be more. And if the mass is less, inertia will be less. So before we actually move on to the Newton's first law statement, first tell me, any doubts still here? Any queries? Clear? Yes, no, you want me to repeat? Let me know. Okay, apart from Aisha, only Aisha has responded. Others have also understood. Aram, Fatima, Maha, Abdullah.
Yes, ma'am.
Oh, okay. Now we can begin the law statement. So Newton's first law is law of inertia only. That's why we had started with this property. And now for you people, inertia is a very important topic because this is a part of Newton's law. See, this complete chapter is important. From this lesson, no, there is no specific topic that can be considered as important. Any question can come and any topic is utilized. Any topic can be utilized further also. And any question in your school examination also can come from this because all the topics are important in this lesson. And it's Some topics are difficult also, so that's why I'm insisting you to revise it on a daily basis. At least before the class, before the next class occurs, try to revise it whenever you get time. Before the next class, you should be clear with the concepts that have been covered in the previous class. So any doubts, you can ask me later on as well. So Newton's laws, Newton's first law. Newton's first law basically defines inertia also, and this introduces the concept of force. Newton has only introduced the concept of force. Introduced the concept of force. So now what will happen? See, acceleration you have studied. Mass was a basic or intrinsic property. Fine, mass was the fundamental property that we had studied in chapter 2. That mass is a basic property, fundamental property. Then from chapter number 3 and chapter number 4, we have added one more property to it. That is acceleration, velocity, displacement, these properties. Now in chapter 5th, you expand one more topic and get the concept of force here. So mass, acceleration, now one more topic you have in your knowledge, that is force. So this chapter will deal with force mainly. So statement is what? See, body will maintain its inertia. Means if it's in the state of motion, it will be in the state of motion. If it's in the state of rest, it will tend to maintain itself in the state of rest. Whatever is the state of the body will try to maintain it unless and until any external force occurs in nature. Any external force occurs to change the direction, to change the state from rest to motion or motion to rest. So statement is body will maintain its inertia unless an external force is applied on the body. External force can change your inertia. I'll write down the statement as well. See, if external force means, see, there are two types of forces that occur. Internal forces are also there and external forces are there. Internal force means, for example, I am standing on ground. Ground will exert a force on me. So that becomes an external force that is coming. Or you can say someone pushes me. So that force that has been occurred by the other person, that we say that is the external force. But if I am stretching my hand and I'm applying tension in my muscles or simply force. So this is intermuscular forces. So this is some internal force that is occurring. But when you deal with your physics, you have a system. System means the references which you're talking to. For example, if I am talking about myself, ground, and the person who is pushing me. So we three are the system. The rest of it becomes the surrounding. This you will see study in thermodynamics, in chemistry and physics, both state, system and surrounding part. Isolated system also you will get this term. Let me tell you that. So system means what? Right now, if I'm talking about the force that is occurring, so that force, my body and the ground, if I'm talking about the ground, then this becomes the system. So any force that occurs within us three, that becomes internal force. And if the force comes from outside, apart from the three, ground, me and the person who is pushing, then that becomes the external force. If I say I am standing on the ground is exerting a force on me, that's why I'm able to stand, that becomes what? Myself and the ground is a system right now. So any surrounding is external for us. ground and me. So what will happen if a force that comes from outside, so that becomes an external force, but the reaction that the ground is giving me and the force that I am exerting to the ground, that is the internal force. So internal force and external force, you just have to understand with the reference of the system. If your system is a spring and pendulum system, then any other force will become your external force, and forces that are occurring, or the tension that is occurring in the strand of the spring, that will become your internal force, like this. So external forces are there, they can change the inertia. External force can change inertia of the body. Now see, this inertia we are discussing, one was I was referring when from rest motion into motion the person is going, and one is from the motion the person is going into the state of rest. So inertia is also not of a single type. Inertia also, you can categorize inertia also into three major types, which you have to understand and remember. These types of inertia, this is easy to remember because it's based on name. So types of inertia. First is inertia of rest. It means body has a tendency to maintain which state? State of rest. Simple definition. So inertia of rest means body tends to maintain its state of rest. So if I'm able to resist this rest state, that means I'm able to resist the inertia of rest. That is inertia of rest. Fine. So example, you can take the example in the bus, the passenger who is there, the upper body tends to move forward. Fine, because the bus has started moving. So you tend to move your body forward because of the bus's motion. This example you can write. Examples, you have lots of examples in other books also, you will be able to find it. Then you have what? You have inertia of motion. So from the name only, you can figure it out. Inertia of motion. Now, which state will be resisted by the body? State of its motion. So inertia of motion, body tends to maintain state of motion. Fine. State of motion, the person maintains this. You can take the example. If suddenly a brake occurs, brake is applied. So what happens? Our body was moving, was in motion. The state was state of motion. As soon as the brake is applied, we tend to fall forward because the body was in the state of motion. And now what is happening? Suddenly brake has been applied. Suddenly your body cannot go into state of rest. So first state of motion is overcome, then you go into the state of rest. So this is simply inertia of motion. So examples, as I'm saying, examples, you can find various examples on inertia. Normal examples, you can refer to books as well. In your NCRT, certain examples are also mentioned in the starting paragraph. Last is inertia of direction. Now, inertia of direction means if I am moving towards the right, so I'll tend to move towards the right. It means in a straight line. For example, if I am moving in a straight line, my tendency will be to move in a straight line only unless and until some force, external force has pushed me to move towards the other side. So this tendency to maintain the state of rest, this is known as inertia of direction. So in action, if the external force is not present, you maintain your same direction. In absence of external force, body will move in a straight line or whatever direction you can write. For example, if a body is covering circular motion, that example also you can take. Circular motion specifically, we have a topic in this lesson only. But if some direction is changing, or you can take this example. See, a car is moving, let's say with velocity 10 meter per second. At this time also, at this point also, the car is moving with 10 meter per second. So what has happened? There is no change in inertia. That's why only the body was not able to change its state. So there is no inertia. It means there is no external force. That's why the body is not changing its state of motion. Here also the body is in state of motion. Here also the body is in state of motion. So there is no change in inertia. Fine. This you can understand that inertia will get changed only if your external force is present in also. So first note down till here any queries you have asked me. This is a very basic topic. I know most of you must be aware of this topic inertia. But still, if you have any queries, let me know. I'll clear it. Okay, next is before we begin with Newton's second law, let's wait for 2 more minutes, then we'll start. Okay. See, now before we start with Newton's second law of motion, we have to understand the concept of momentum. Momentum means how much motion or the amount of motion that is there in the body. Momentum is simply amount of motion in the body. It means if a body is moving even after some external force has been applied, that means the momentum in the body is so much because of which the body is moving. So that amount of motion which is present in the body, that is termed as momentum. Or you can also define it, a body is there whose mass is m, and this is moving with velocity v. So momentum is what? Momentum, this is denoted by a capital P. So momentum is what? Momentum is simply product of mass into velocity. This is known as momentum. This P is your momentum. M is the mass and V is the velocity. So velocity you are aware of, mass you already know as it's a fundamental property, and momentum you know. So it's what? It's a vector quantity. And if it's a vector quantity, will it have a direction or not? Yes or no?
Yes.
Yes, definitely.
Yes.
Vector quantities have direction. So direction of momentum is easy to remember, because whatever is the direction of velocity, exactly that is the direction of momentum. So the direction is same as that of velocity. If velocity is acting, let's say, towards north, so momentum will also act towards north, but direction will be there. And direction will be there. If I have written it's a vector quantity, it means direction will be there, magnitude will be there, and it will obey the vector laws. That is parallelogram also law you can apply for if there are more than a single vector momentum present. Fine, triangle law, polygon law, according to most probably this parallelogram law will only get used. So this is what P is equal to mv. SI unit also. See, SI unit, you people can figure it out yourself also. Mass into velocity. Mass's SI unit is kg. So mass into velocity, meter per second. Got it? Mass multiplied by velocity. For example, how the questions come in your exam. A body or let's say of mass 10 kg, is moving with a velocity of 5 meter per second, calculate its momentum. Means how much motion is still left in the body, or what is the magnitude of motion. So momentum is what? Mass multiplied by velocity. 5 into 10, that is 50 kg meter per second. Easiest question that is possible. Fine. And remember this fact also. If momentum of a body is changing, it means inertia is changing. Momentum changing means inertia. Inertia. Inertia is changing. Fine. If momentum of a body is changing, it means inertia is changing. And it can also happen the external force that is applied is not zero. So that's why you can say momentum of the body is changing. Any of these factors can occur if the momentum of the body is changing. So this was the concept of momentum. Now as I've told you, first we did inertia, then we discussed the first law of motion. Now we have discussed momentum. So definitely Newton's second law of motion is based on this only. So Newton's second law of motion. We'll do only 2 laws today so that you can revise these 2 laws. After this, we'll do simple, easy numericals, and I'll stop. So you people can get clear with Newton's first and second laws of motion. Fine. Assignment also I'll share it with you today. Newton's second law of motion. Before we start with Newton's laws of motion, first tell me, momentum is clear or not? Yes or no?
Yes.
Yes.
Okay. What about you both, Abdullah and Fatima? Yeah? No. Abdullah? See, Newton's second law directly introduces you to the force. As I've discussed you that this chapter introduces to force, majorly it's your second law. It's relation, it gives you a relation to measure force. See, in nature, force exists. That is given by the first law, because obviously force is existing. That's why you are able to see all these properties of inertia, be it in rest or state of motion or any. But what's the magnitude or the amount or the measurement of force? That is given by the second law. So it's a relation to measure force. So second law of motion states that external force acting on a body is equal to its rate of change of momentum. Now I'll explain you what is meant by this. See, there are 2 terms that you will get in physics throughout. One first term is rate, second term is gradient. I think I've discussed it with you all also. I'm repeating it. Rate means what? Rate means when any quantity which is changing with respect to position, with respect to distance, that we say gradient. If I say velocity divided by distance, that will give me velocity gradient, because amount of velocity change that is occurring with respect to distance. So first term is gradient. Then you have a term that is known as rate. Rate means what? Rate means when any quantity changes with respect to time. For example, if I say velocity divided by time, so that is acceleration. That's why I say no, acceleration is rate of change of velocity. Rate of change means what? Something that is changing with respect to time. For a duration of 1 second, something is occurring. After 1 to 2 second, other quantity is occurring, then other quantity is occurring, likewise and so on. So rate means any quantity that changes with respect to time, and for better understanding and remembering for your exam, you can remember directly by dividing it by the time. So rate of change of momentum means divide momentum by time. And dividing momentum by time. See, let's say delta P is the change in momentum. And let's say delta T is change in time. So rate of change of momentum means what? Rate of change of momentum means momentum divided by time. So delta P divided by delta T. This is what? Second law says that this is equal to your F external. This is how you calculate the magnitude. Delta P, you can calculate it in this way also. Final momentum minus initial momentum. Yeah, because you're actually calculating the momentum difference. Remember we did average velocity and instantaneous velocity, average acceleration, instantaneous acceleration. So whenever we had average term, we used this delta symbol. But whenever we had that instantaneous term, that we used in the differentiation. So here what are we getting? We are getting the average force. Why are we getting the average force? Because it's the delta change in you are calculating for a larger number. If it's a very infinitesimal small change that is occurring, so you will write F external as dp over dt. That is, you will differentiate momentum with respect to time. This gives you instantaneous force. Instantaneous force. Fine. So see, one more thing you have from here, you have a very small but a very important derivation, very small derivation you have. Major derivation, no, these are present afterwards, especially you have it in your chapter 6 and chapter 7. Here also very small and easy derivation is there. See, momentum is what? mv, mass into velocity. Fine? Agreed? And what is force? External force is equal to rate of change of momentum. So I can write the value of momentum from here. This becomes d. Instead of p, I will write mv. Fine? Rate of change of momentum. Now, mass of the body is, if the mass of the body is constant, that is also one more condition. If I say the mass of the body is constant, so I can I write m over here and I will write dv over dt. What is left? Can anyone of you tell me what is dv over dt? Anyone?
Acceleration.
Acceleration. Perfect. That is acceleration, rate of change of velocity. So from here you get your, this is acceleration. You get your final formula, F is equal to ma. This formula you have already studied in your lower classes. Derivation you didn't have in your syllabus. I don't know whether it was done in your school or not, but now you have to remember F is equal to ma. So basically F is equal to ma is Newton's second law. And you also have to remember that here the mass has to be constant. Otherwise, you cannot take m out of this differentiation. You have to differentiate mass as well. And force is what? Force, it's a vector quantity. Fine. It's a very important quantity that is present because it is existing everywhere. SI unit is based on the name of the scientist who discovered it. That is Newton. Newton, it's the SI unit. One thing you have to remember, that is CGS unit. Mostly everything was given in SI unit and the answers also have to be written in SI unit. CGS unit is dyne. But if you have to convert CGS unit somehow into SI unit because CGS unit is given, or in any of the calculations you wish to change Newton into dyne, see there is one relation. 1 Newton is equal to 10 to the power 5 dyne. this relation. So any of the conversion, if any of the conversions are involved, you can use this. CGS unit is what? Dyne. I hope you understand what are CGS and an SI unit. See, SI unit is a standard unit that defines the unit for every quantity. For example, distance is meters. CGS means centimeter gram seconds. So this is a scale, a lower scale for conversion. For example, centimeter is written. So for distance, for length, centimeter is the CGS unit, but meter is the SI unit. So likewise, for every physical quantity, you have SI unit as well as a CGS unit. But remember, you have to give your answers in SI unit only. So answer in Newton only. And just write capital N for Newton. For example, it's written 4 Newton, a force acting of 4 Newton. So like this, we write it for force. So force is a very important concept. Force, all of you use this term often. Numericals, let's do, but before that, you note it down. Any doubts in here? Let me know. I'll clarify because this is a very basic chapter as I'm repeating it constantly. This lesson is very important. Any doubts you have? So I'll stop the theory part over here right now. 2 laws we have done, 2 new concepts, inertia and momentum we have done. Please revise it. At least take out few time, even if you are having your exams going in school. Take 15 minutes for revision. The theory portion is very less in this. Numerical, whatever I'll do, just revise that. Fine, that will be sufficient for the next class, Monday. See, yes, mass is constant. When mass constant is given, then only you can use the formula F is equal to ME. If by chance your mass is not constant, then you cannot use the formula F is equal to MA. That time F is equal to dP over dP or differentiation of mv by dt you can do. But in your case, in your class level, you will get mass constant only, like 5 kg, 3 kg, like this. If it's variable, that we'll see later on. But for mass constant, then only you can apply the formula F is equal to MA. See, balanced force means when your net resultant forces are cancelling each other. For example, upwards one force is there and one force is acting downwards with equal magnitude. Then you say your force is balanced because both the forces are cancelling each other. We'll see normal reaction, that is the ground force that occurs and the force that you will exert on the ground. So that is balance. You are in the equilibrium state. Unbalanced force means where one of the magnitude on the greater one side is greater than the other. For example, if you have weight, then we'll study mg also, gravitational force. So there you will see if the gravitational force's magnitude is high, then the body tends to fall downwards. So that is unbalanced force because your forces are not getting balanced with each other. So that results into state of unequilibrium. That can be stable or unstable. This is totally unequilibrium condition, unbalanced force. Got it? Just text me done once you have written, then I'll stop the class. Numericals we'll do in the next class only. Okay, so most of you have completed. In the next class, we'll continue this. Please be prepared for the test. A short test I'll take on Monday as well on topic angular projection